tomorrow. This unit is really taking everything you've learned so far with graphing. So we started with absolute value and square roots and quadratics and cubics. Then we went on to polynomials and radical rationals. And we're just going to do stuff with them. We're going to add them, subtract them, multiply them, divide them, and then do something that's called the composite. This unit doesn't have the y attached to it because that's in all of the sciences, in business, in engineering, anything you go on to. So if you're one of the person that needs to know the why are we doing this? This unit isn't going to do it for you. This is just the how, so that when you get into whatever field you're going to get into, you know what to do when you get there. Okay, so not a lot of why, just let it go, just deal with it. So what we're doing today is called combining functions, which is adding, subtracting, multiplying, dividing. So we're going to take a parabola and a square root and add them. We're going to take a cubic and, I don't know, absolute value and divide them. And let's find out what happens when we combine functions. We're going to do it graphically first, then we'll do it algebraically. So to find the sum, difference, product, quotient of two functions, we either add, subtract, multiply, or divide the y coordinates, and we leave the x coordinates unchanged. So example, here's two functions, f of x and g of x, and we want to find h of x if it equals f plus g of x and plot it on the same grid. So this is saying we want to take the two functions and add them. So we want to know if we take a parabola and add a line, what's going to happen? I'm left-brained, so I do it with a table. If you're not left-brained and don't like the table, don't feel you have to use it. We're going to start with table of values. So give me some x values. Pick any x value that you like. 0 and 1, I heard. Give me 3 more. Can we have some negatives just to mix it up? Ooh, negative 6 and negative 9. Because he felt like it. Nothing wrong with that. Okay, so you might want to make a note so when you look back, we chose these. So these are random values. You can pick whatever you want to pick. What we're going to do first is find what are the corresponding y coordinates on the f of x function. What are the corresponding y coordinates on the g of x, and then we're going to add them. So I'm a ruler person. If you like doing rulers before when we did transformations, you might want to join me on this. So f of x is labeled as the parabola. 0 means we're putting where the x equal to 0, and we want to know what's the corresponding y coordinate on the parabola. He needs a ruler from the box. Okay, so I just put my ruler right on 0, and I'm looking at the parabola, because that's labeled f of x, and I want to know what's the corresponding y value. 0. Now I'm just going to move to the next x value we chose, so I'm going where x equals 1. Again, we're doing the parabola right now, so what's the corresponding y coordinate? Offer of 1. Okay, next one we chose was 2, so I'm moving over to 2. Looking at the parabola. Ooh, I heard 4 and negative 4. 4. Negative 6. So off our graph, but if we look at the shape of the parabola, we know it's just the base parabola. So we can use a little bit of logic to say negative 6 squared is going to be 36. And negative 9 squared is going to be. So in hindsight, probably not great values, but it's okay. We can pick any value we want. Now we're going to do the exact same thing, except instead of looking at the parabola, we're going to look at the line, which is labeled g of x. So x equal to 0. Look at the line. What's the corresponding y value? Move over to 1. Offer of 3. Move over to 2. Offer of 6. Ooh, correction of 5. Confirm 5. Okay, move over to negative 6. Offer of negative 11. Negative 9. Offer of negative 17. Yes, with the question mark. In hindsight, it's not going to matter anyway because it's going to be off the graph. Let's just pretend it's negative 17. This question has asked us to add, so what we're doing is taking f of x plus g of x, so we're physically adding. What's 0 plus 1? 1. What's 1 plus 3? 4 plus 5. 36 plus minus 11. And 81 minus 17. What we're graphing are the original x-coordinates, because they don't change when we combine functions. And we are going to graph the addition. So those are the new coordinates we're going to graph. Now let's think about this logically. Let's use our good math logic skills. Before we actually graph it, what do you think it's going to look like? What's going to happen when we add a parabola and a line? Well, what's the degree of a parabola? 2. And what's the degree of a line? And can we change the exponents when we add? So when we add like terms, do we ever change the exponents? No. The only way to change an exponent is to multiply or divide. So when you're adding functions, you can't up or decrease the degree. So when you add a parabola and a line, what's it going to look like? It's going to end up looking like a parabola. Okay, so the only way you can change a degree is to multiply or divide. So 0, 1 is our first point. 1, 4. 2, 9. Negative 6 off the graph. Negative 9 off the graph. So we have this side. How can we use some logic to get the other side of the parabola? It's symmetric. Okay, so what's the difference between our first 2 points? So over what and up what? Over 1 and up 3. So what do we do on the other side? Over 1 and up 3. So there's just some logic to get the other side because we didn't happen to pick those x values. There's your first combining of functions. Parabola and a line makes the parabola. How are we feeling? Here's our 2 graphs we're given, f of x and g of x. Name them. What kind of function is f of x? Linear. What's g of x? Absolute value. How do you recognize an absolute value? Yeah, it's got the V shape. What does the question want us to do with them? Subtract them. So make sure you're reading carefully and your brain doesn't skip over that minus, because you're going to want to add, because that seems really familiar. This one is asking us to minus. Pick some x values. Maybe we can go from smallest to largest this time. So give me 2 on the negative side.
-2, -1.
And we usually like to pick 0 because it's in the middle, and then. So typically those are the normal points we pick, but again, you can pick anything you want. It's not going to matter. Okay, if you're into the ruler, plunk your ruler at -2. And what I'm going to do this time is do both the f of x and g of x at the same time, so we don't have to move the ruler and go back. Just make sure that you know which is f and which is g. So f is the line, so give me the y value at -2 for the line. Offer of -7. Now look up at the absolute value. Give me the y value of g of x. Offer of 2. Confirm? Confirm? Okay. Just make sure you're really watching which one is f of x and which one is g of x. Same thing at -1. So f of x first. Offer of 6. Correction of -6. Confirm? Okay, g of x. Offer of 1. Okay, over to 0. Confirm -5 and 0. Over to 1. Confirm -4 and 1. Talia, take your earphone out. And over to 2. -3 and 2. Confirm. Okay, top of this column is just what we're doing, and the reason I left it blank is so your brain actually stops and looks for the question what we're doing. Okay, so we're minusing, so we're going to put a minus in front of all of these guys. Okay, so -7, -2. -6, -1. -5, -0. -4, -1. -3, -2. That's interesting. Okay. Again, the x is the first coordinate you're graphing. The last column is this y coordinate. That's why I highlighted those ones for you. Why isn't g of x? Because we're subtracting, right? So I just put them in so visually we can see what we're doing. Okay, so -2, -9. -1, -7. 0, -5. 1, -5. 2, -5. What do you think is going to keep going on the right-hand side? So what do you notice there on the right? Yeah, what do we call a flat line? What's the math word for that? Yes, there's a vocabulary word. Rhymes with horizontal. Yes, horizontal. Okay, why? Why did this end up being horizontal here? Yeah, when you're subtracting parallel lines, you're always going to get a horizontal line. This side is not horizontal because they're not parallel. Domain and range. Offer for domain? Confirm? Nobody confirming? Okay, range? Including -5 or not including -5? So round bracket or square bracket? Square bracket. Confirm? Questions so far? Yes, this is as hard as it gets. I'm so excited for number 3 because you're going to see a shape of graph you've never seen before. And don't blurt it out when we draw it, but I want you to think what we call it. Remember, mathematicians, not creative people. So I will ask you when we're done what we call it. Do not blurt it out and spoil it for people. Okay, g of x is linear. F of x is? It's a swoop is the shape, but what kind of graph is it? Square root graph. Okay, pick some x values. -2 is not a great value to pick, and let's look at why. Because we don't have a square root there, right? So the smallest one we can pick is? Okay, give me some more. It bothers the left brains. Those are not in order. Like, really, I'm starting to twitch. I'm like, it's okay. I'll deal with it. I can do it. I can do it. I can do it. I can do it. We can be willy-nilly. Come on. We can do it. We can do it outside the box. If you like the ruler trick, do the ruler trick. If it does nothing for you, don't do it. Just watch the order. Make sure you're giving f of x first, then g of x, because if you mix them up, it might matter. F of x at -1. And g of x at -1. So offer of 0, -4. Okay, move over to 0. Offer of 1 and -3. Okay, move over to 3. We can do it, we can do it, it's okay. Back over to 2. 1 and 2 thirds, can we go to 1 decimal point? So we're estimating 1.6. Are we okay with that? Okay. Minus 1. Back over to 1. 1.3 is the offer. Okay. What does the question ask us to do? Multiply. Okay, so F multiplied times G. Fill in the new column. Hello, where did you go? Who is the tactile child tapping their ruler? You know, it was somebody down here. I'm going to say Patrick. Patrick's tactile. Oh, it wasn't you? It wasn't accusing. I'm just saying. I just know you're tactile. That's all. Yeah. Okay, give me the numbers down the column. Ooh. 0. I'm just wondering where the 0.5 came from. And confirm. What are the coordinates we're graphing? Where do you find that information? And again, if you're not into tables and the table doesn't work for you, you don't need to use a table. It's just how my brain works. Go ahead, draw it, and then silently think to yourself, what would we call this? Do not shout it out and ruin the fun.